Welcome to the Math 1, Unit 8, Lesson 2 summary video, Quilt Blocks Galore. This lesson is a Solidify Understanding task, which takes concepts developed previously and helps you formalize those ideas. The purpose of this lesson is to understand equivalent expressions obtained from factoring trinomials with positive and negative terms using rectangular area models. We're continuing on with Quanika's quilts that we explored in yesterday's lesson, and the first question in the task today tells you that we're going to start with our original square quilt, which is x by x inches on each side, and so it has a combined area of x squared. Then it tells us that we're going to extend the length of one side by 2. And so we can label that new length and width as such. And when we write that expression, the length times the width, in order to find the entire combined area, we have x times x plus 2. And as we discussed yesterday, once we distribute that x to each of the terms inside the parentheses, we get a combined area of x squared plus 2x. And we can see that in our model we have one x squared block, and then we have a rectangular block here and a rectangular block here, each with an area of x, which gives us 2 x's. And so we can see how this expression relates to this expression and how both of them relate to the area model. In today's lesson, we're going to start looking at how we could model taking some of the length or the width off from one side of the quilt or both sides of the quilt. So as it stands, as we just looked at the last example, we had a length of x units plus 2 inches by a length of x units. Well, if we wanted to keep this side x units long, we don't want to change this dimension at all, but let's say that on this side we want to start with our x, because we talked about that yesterday, that we're going to always start with this x squared block of quilt. But let's say now that we want to reduce this side length by 2 units. So instead of adding 2 inches, we want to take 2 inches away from this side length. And just like when we added, we put plus 2, now we're going to subtract 2 from this side length of x. And so that would look like this when we wrote that out as an expression of our length times our width. And when we distribute that, we get a combined area of x squared minus 2x. And we explored this a little bit yesterday. Here we are taking away 1 inch, that represents this side length, and we're taking away 1 inch here, which represents this side length. We know that if this side length is x, this side length is also x, and so the area of each of these rectangles would be -1 times x, which gives me the area of negative x. -1 times x gives me negative x. So my area, I've got an x squared, and then I've got 1, 2 negative x's. Let's look at another example. In this example, we're going to start with our original block of quilt, which is x by x. And this time we're going to we're going to add 2 inches to one side. And so we're adding a 1 inch here and a 1 inch here. And then on the other side, we're going to take 3 inches away from the other dimension. And so each of these side lengths is a -1. So again, we've got the x here, x length here, which makes this x, and this side is -1. So x times -1 gives me an area of -x. And it's the same thing for each of these. This dimension is 1, this dimension is x. We have 1 times x, which gives me an area for the rectangle of x. And the same thing here. And just like we did yesterday, we know that we have to fill in this rectangle. We're making a quilt and it needs to be rectangular. And so we need to add in some unit tiles to fill this in. So again, we already said that when we added 2 inches to this side length, that makes this dimension and this dimension, they are each 1 inch, which makes this dimension 1 and this dimension 1. And over here, we've got the -1, we took an inch away. So each of these dimensions are -1, which makes this dimension -1, -1, -1 for each of these dimensions. So these blue unit blocks have dimensions of +1 by -1. And we know that when we multiply +1 by -1, we end up with a -1. So we need to make that a negative block. It's going to be the same thing. This is +1 by -1. So that's going to be negative, positive by negative, positive by negative. And the same thing down here. So if we look at our expression here, we've got x plus 2 for our length times x minus 3 for our width. And when we distribute our x to each of the terms in our second factor, we have x times x, which is x squared, x times -3, which is minus 3x. And now we're going to distribute this +2 to each of the terms in our second factor. So we've got 2 times x, which is 2x, and 2 times -3, which is -6. We're going to simplify by combining our like terms. And we have x squared. We have -3x and 2 positive x's, so 3 negatives and 2 positives. That's going to give us a -x minus 6. And if we count up all of our area, we have an x squared here. That's this. We have 2 positive x's, and we saw those right here, and 3 negative x's, and we saw that here. And we know that these are 0 pairs, so for every positive and negative x, if I add an inch and I take an inch away, I'm going to end up back at 0. That's a 0 pair. We have another 0 pair here, and so what we're left with is 1 negative x. And so that's here. And then we've got our 6 negative 1s, which is -6, and we can see that in both of these. So again, we can see that this expression and this expression are equivalent, and this area model represents both of them. In fact, this is also equivalent, it's just not simplified. One other thing I'd like to point out, if you notice here, we added 2 inches, or we added 2 x's. Here, we took away 3 inches, which gave us 3 negative x's. So when we look at what we were left with negative x. If we're taking away more than what we're adding, we're going to be left with a negative middle term. If we're going to add more than we're going to take away, we're going to be left with a positive middle term. And if we look up here in the first 2 binomial factors that we used, we can see that our constants, the 2 and the -3, the -3, we have more negatives than we do positives. which tells us that our middle term is going to be negative. We can also look at these last two terms in our factors and notice that if one is positive and one is negative, our constant, or our third term in our trinomial, is going to be negative. Again, this is a trinomial because it's got 3 terms. These are binomials because they have 2 terms. It's important to note that many students will think that if we start with our original square that's x by x units, if we add 2 inches to one side and we take 2 inches away from the other side, many students would think that we would be left with the original square, which had an area of x squared. We know that that's not the case, 1, because we can see it with our area model, but 2, because it's not linear. It's square, and we're talking about the inside area. And in the last example, we talked about how these are 0 pairs, the positive and the negative x. They cancel each other out because if we add an inch and we take an inch away, we end up with 0. But because we are finding the area, we're completing this square, or in some cases the rectangles, we have these 1 units, or the unit cubes, left over. So even though these are canceling out, what we still have left is the x squared and all of these negative 1s. And what that looks like once we distribute, we've got the x times the x, x squared, x times the negative 2, negative 2x, 2 times the x, and 2 times the negative 2. So we've got 2x minus 4. And this is that 0 pair that we're talking about. This is how it cancels out. We've got negative 2x plus 2x, which equals no x's. If I have 2 negative x's and I add 2 x's, I have none left. So we're left with x squared minus 4. In the last section of the lesson, you are given the trinomial and you're asked to find the binomial factors that are used to create this. So again, we're starting with our original block that's x by x units. If I look at this, what I notice is I have my x squared. I have to end up with 3 positive x's, and I have to end up with 10 negative 1 cubes. Well, I know from the previous examples that we've done that the only way to get the negative cubes, the negative unit cubes, is to multiply a positive x by a negative x. And so when we added 1 to one side and we took 1 away from the other side, I know that I ended up with a negative 1. And so we can use that to kind of help us. If I do that again, I'm left with, now I've used 4 of my negative 1s, and I still have 6 to go. So if I add another 1 to each side, now I've used 9, but I only have 1 left. And so if I were to add this positive x here, I don't have enough unit cubes left to complete this rectangle. And even if I took it away from the other side, I would still have the same issue. I don't have enough of these. So it can't be that I'm adding 4 to one side and taking 3 inches away from the other side, or vice versa. So let's see what happens if we take one of the negatives and make it a positive. If we do that, now we can fill all of these in. So if we have 5 x's, 5 positive x's by 2 negative x's, then we can fill in all of these negatives. One other thing to think about and look at is, what if we were to have the 5 negative x's and the 2 positive x's. We could still use all 10 of these negatives. But what we know, what we looked at in the last example, is that when I cancel out my 0 pairs, what I would be left with would be 3 negatives, and I don't need 3 negatives, I need 3 positives. So this scenario won't work. We have to move it back, and so I need these to be positive. So now when I cancel out my 0 pairs of x's, I'm left with 3 positive x's, which are here. I've got my x squared, my 3 x's, and I've got my 10 ones. And so what I did was I added 5 to this side, and I took 2 away from this side. So the area model can help you, especially in the beginning when we're factoring these trinomials, until you get used to doing it. So on one side we added 5, and on the other side we took 2 away. And we know that if we distribute the x and the 5 to each of the terms in my second factor, I'll end up with this trinomial. But eventually we should start seeing some patterns. And so what I know is that when I distribute this x to each of the terms in the second factor, I had the x squared and then minus 2x plus 5x minus 10. And each time when I do this, I'm simplifying my x terms. And we talked about this earlier, that if I have more positives than I do negatives when I'm adding these, I'm going to end up with a positive middle term. Likewise, if I have more negatives than I do positives, I'm going to end up with a negative middle term. And we know that in order to get a negative third term, I have to be multiplying. I get this negative 10 by multiplying the last 2 terms in my binomial factors. So I'm multiplying this positive 5 by the negative 2 to get me this negative 10. So I know that I've got to have I have to have numbers with different signs in order to get this negative. I know that if my second term is positive, I've got to have more positives than I do negatives. And so when we're thinking about creating our binomial factors, we're starting with our x's in order to get that x squared. If I am adding a number in each of these factors, then I'm going to end up with a positive second term. I'm also going to end up with a positive third term, because I'll be multiplying 2 positive numbers to get that. If I am subtracting a number from x and subtracting a number from x, here I'm going to be adding this. When I distribute this x here, I'm going to have negative x's, and when I distribute this number to this x, I'm going to have negative x's. So when I combine my like terms, I'm combining negatives, and when I add negatives to negatives, I get more negatives. So if both of my factors have subtraction, then this second term is going to be negative. I also know that I multiply my last 2 term, or my last term in each factor, to get the third term in my trinomial. So if I'm multiplying a negative by a negative, I'm going to get a positive third term. So if both of these are negative, my second term is going to be negative, but my third term will be positive. And then if I am adding a number and I'm subtracting a number, this is the only way that I can get a negative third term, right? If I multiply a positive times a positive, I'll get a positive third term. If I multiply a negative times a negative, I'll get a negative third term, a positive third term. Here, I've got to multiply opposite signs in order to get that negative third term. Depending upon which number here has the larger absolute value, which number I have more of. Do I have more positives or more negatives? That's going to tell me the sign of my second term. If I have more positives, I'll have a positive second term. If I have more negatives, I'll have a negative second term.